my second video in my module on solving radical equations, and in this video we're actually going to explore equations that have rational exponents. So just really quickly, let's go ahead and take a look at these examples here. I'll work through with you and kind of break down the process for us. But let's consider this very first statement here. It says 2x to the 3/2 power is equal to 250. What we really want to acknowledge is this. This really, if we wrote this as a radical expression, we say x would be the base. It's being taken to the third power and it's the square root. So I suppose we don't have to write that out there. We're saying that this equals 250. So now, the only thing I want to mention here is this. It's a little bit harder to solve these equations. That is, in the last video, what we would do is we would divide both sides by 2 to get this by itself and then have to square both sides, and then I'm going to have to turn around and take the cube root. What we're going to do is take an approach that basically suggests that you should leave it in rational exponent notation. So here's what we're going to do. In the last video we said 1, isolate the root. What we're going to do is 1, isolate the base of the exponent. I can scribble today. Isolate the base of the exponent. And so what I mean here is essentially this. We have 2x to the 3/2 power equals 250. If I'm looking for x and x is inside this, rational exponent expression, then what I need to do is I need to start by getting everything else out of the way, like divide by 2. So the first step here would basically indicate that we want to get this by itself. And there's a reason why we want to do this, because the very next step is going to be this. We are going to exponentiate, okay? So exponentiate. This is a funny word that basically means this. If two things are equal, if a equals b, then a to the n equals b to the n, as long as these are the same and as long as these were equal to begin with. It basically means if I had an expression like this, I'm allowed to do the same power to both sides. So we're going to exponentiate both sides to the power of, let's put it this way, to the reciprocal power of the existing power. So essentially what we're going to be doing in situations like this is this. We know that the power to a power property says that if you raise a power by another power, you can actually just multiply the exponents. And here's what we also know, algebraically speaking. We say that anything times its reciprocal is 1. So what we're really trying to do here is get x to the first, or just x. So we say that x is equal to 125 to the 2/3 power. Now what I can say is this. This is an instance where we could actually evaluate this on our own because, it's a power of 3 here, essentially, or power of 5, but 3 times. Here's what I'm trying to say. This works out as an integer value. Otherwise, what we could do is we could actually go grab a calculator and check this here. So what I'll do is I'll actually grab the calculator and check it first. So we say 125 to the power of, and we say in parentheses, 2 divided by 3 end parenthesis. So we would get 25.04. You notice that we get that, but we don't get exactly 25, which is actually what it comes out to be. So using a calculator, you're going to lose some accuracy. But what I really wanted to do was essentially this. We'd say, what's 125? Let's start with the root first. Let's do the cube root of 125, which is 5. So we get 5 to the now 2 over 1, since we have already done the root part, and this turns out to be our 25 right here. So really quickly, let's solve this other one. The first thing we want to do is this. We want to isolate the base of this exponent. So we're going to divide both sides by 3. So we get x to the 4/3 power is equal to 243 divided by 3, which is 81. Okay. So now what I want to do is this. Step 2, I want to exponentiate both sides to the reciprocal power of the existing power. So we say the reciprocal of 4/3 would be to the 3/4 power. That's what we're going to do. But we have to do it to both sides because that's our equality equality property. So those cancel out and we get just x to the first is equal to 81 to the 3/4. Now I want to do this one not on the calculator first, but I'm going to say, well, what is the 4th root of 81? Remember, we always want to do the root part first. I say the 4th root of 81 is 3. So I still need to do 3 to this 3 over 1 power this time. And we say that I get 27. Okay. So the last thing I want to write here is this. Once you exponentiate both sides, I suppose we could say simplify your solution. And then 4 is check your answer. Okay, so check answer. So really quickly, just on this one here, I want to check this answer 27. If we were to plug this back in, 3x to the 4/3 power equals 243, then I would have said that this right here, we said that x turned out to be 27. Whoops, we got 27. Let me get this out of the way here. 27. And we say the cube root of 27 would be 3, so I get 3 times 3 to the 4 over 1 equals 243. So now I get 3 to the 4th. Okay, oops, did that again. Apologize. So 3 to the 4th So I get 3 to the 4th is 81, it's 243. And then we say 3 times 81 is 243. So you can see how this works out. So that is how you solve a radical equation with rational exponents.